In one of its first images, the James Webb Space Telescope captured a galaxy named Glass Z13, which set the record of becoming the oldest galaxy ever observed by astronomers, forming just a mere 300 million years after the Big Bang. The telescope has been fully operational since July 11th, and it's already stunned scientists with its sharp images and fascinating discoveries. Get ready to learn how the James Webb Space Telescope has already detected an exoplanet with one of the main conditions for life, made an image covering an area of the sky 1/5 of the Moon's diameter, and showed us Jupiter's rings like never seen before. The James Webb Space Telescope has many advantages over the Hubble telescope. Webb operates at a distance roughly 1.5 million kilometers from our planet, which is 4 times farther than the Moon. At this distance, there's no interference from space stations and satellites that affect the Hubble telescope's images, which operates 547 kilometers from Earth. In addition, the Hubble telescope mainly observes in the visible and ultraviolet light bands. The JWST is equipped with the NIRCam for near-infrared and MIRI for mid-infrared spectrum. Astrophysicist John C. Mather believes the telescope is so powerful it could detect a bumblebee hovering in space at the Earth-Moon distance. Infrared vision allows the telescope to look at the edge of the universe, where the oldest galaxies and stars are hiding. The Hubble Space Telescope is unable to penetrate the powerful veil of gas and dust that surrounds many planets, stars, and galaxies, but JWST penetrates everything like an X-ray. One of the biggest differences is the JWST mirror, which is 6.5 meters in diameter. It can take in a lot more light and is the largest mirror ever sent into space. It's almost 3 times as large as Hubble's 2.4-meter mirror. Thanks to such unique equipment, the first images made by JWST were surprisingly clear. Even faintly luminous objects were visible in this image. You can see the deepest and clearest view of the early universe to date. JWST captured it in just 1 day, while the Hubble telescope took several weeks to collect similar deep-field images. The deep-field image from the JWST shows thousands of galaxies. In the middle, you can see a group of galaxies that are part of a galaxy cluster named SMACS 0723. Their combined mass acts as a gravitational lens, refracting light rays from more distant galaxies behind it so they appear warped. Many galaxies are so tiny and dim that no telescope has ever detected them before. The starting point for the JWST was our solar system. This is Jupiter as it was captured by the telescope. Scientists decided to get an image of the gas giant while the telescope was still being tested. Since then, the planet has been involved in many photo shoots. This was a way for researchers to assess the real capabilities of JWST, and it exceeded all expectations. The James Webb Telescope was able to clearly see the planet's famous stripes, resulting from complex atmospheric phenomena. It also captured the Great Red Spot, a mysterious giant storm 16,000 kilometers, 10,000 miles, wide and powerful enough to swallow the entire Earth. Jupiter's satellite Europa can be seen on the left, and there are also images of the other moons Thebe and Métis. JWST also captured some of the planet's rings. That's right, Jupiter has rings. Detecting and capturing the gas giant's faint rings is incredibly difficult, as they're hardly distinguishable near bright objects in space, including Jupiter itself. Following this, the telescope shifted its gaze towards the very distant WASP, 96b exoplanet, and immediately delivered stunning results. Astronomers discovered the planet back in 2013 in the constellation Phoenix. They found out that it's a gas giant located roughly 1,150 light-years away from us. It has a mass less than half of Jupiter's, but a diameter 1.2 times that of Jupiter. Because of this, the exoplanet is as puffy as cotton candy. It rotates much closer to its yellow dwarf than Mercury does to the Sun. This heats up the planet to more than 1,000 degrees Celsius. JWST recorded the presence of clouds and haze in the atmosphere of the planet. It also detected traces of water, indicated by the presence of certain gas molecules. In the planet's atmosphere, scientists were thrilled. Hubble has been searching for water for the past 2 decades and was only able to detect signs of it in 2013. JWST made a valuable discovery almost instantly. This is intriguing but not as exciting as it would be to find alien forms of life on WASP, 96b. But astronomers say the detection of biologically significant substances like water, oxygen, carbon dioxide, and methane is the first step on this path. If the telescope finds such substances on rocky planets as well, it would be a clear indication that we should start looking for signs of living creatures there. In another JWST image, you can see the Southern Ring Nebula located 2,500 light-years from Earth. An expanding cloud of gas surrounds a dying star, and this cloud isn't caused by the star at the center but by the star seen below. Over thousands of years, it's ejected at least 8 layers of gas and dust. The bright central star mixes these emissions, creating complex rings of planetary nebulae and piercing them with its radiance. This is also how sunlight on Earth fills in the gaps in the clouds. Hubble had also previously delivered great images of the Southern Ring and many other nebulae. It showed us that these are not just clumps of gas but colorful and extremely complex systems. But JWST did an even better job. Not only did it capture a clear image of the planetary nebula, but also a huge stretch of space behind it filled with many galaxies. The bright thin sliver of light on the left is one of them. Here you can see how detailed the JWST image is compared to the Hubble image. Another difference is the bright stars in Hubble's image have 4 beams, while the stars in the JWST image show 6 points of light. This is because the Hubble telescope has a round lens with a secondary mirror hanging in front of it on 4 extensions. The JWST lens, on the other hand, has 18 hexagonal mirror segments. Now take a look at this stunning image. What is this monstrous purple maelstrom? This is how JWST saw the spiral galaxy NGC 628 or M74, located in the constellation Pisces, roughly 32 million light-years away from Earth. But why does it differ so much from this Hubble image of the same galaxy? This is because JWST had a different task. It had made a detailed examination of the threads of dust and gas that block the light of most stars. Although some stars still peek through the veil, you can also see the aftermath of supernova explosions and areas of new star formations that make the image more dynamic. But let's look at another fantastic image. This is the largest image made by JWST, which covers about 1/5 of the diameter of the Moon. It shows a compact group of galaxies called Stephan's Quintet in the constellation Pegasus, about 290 million light-years away from us. 4 of the 5 galaxies in this quintet seem to be performing a gravitational dance, approaching each other and sometimes colliding, and the 5th one is quietly watching this performance at a distance of 40 million light-years away from Earth. It's a bright and exciting spectacle. True, the Hubble telescope has given us the opportunity to admire it more than once before, but JWST saw Stephan's Quintet in a new light. This huge mosaic was created by astronomers, consisting of nearly 1,000 separate JWST images, totaling more than 150 million pixels. The image shows never-before-seen detail in Stephan's Quintet. We can observe many bright dots, distant background galaxies, sparkling clusters of millions of young stars, entire regions of star formations, wide tails of gas, dust, and stars ejected from several galaxies due to gravitational interactions, and even huge shock waves as the galaxy NGC 7318b pierces the cluster. The uppermost galaxy, NGC 7319, contains a galactic core with an active supermassive black hole at its center, and JWST was able to penetrate through the dense layer of gas and dust into the galaxy's core. The telescope detected hot gas near the black hole and transmitted it with a striking level of detail. Even more new details were revealed by the James Webb Space Telescope in this astonishing cosmic cliffs image. This is the edge of a young star-forming region called NGC 3324 in the Carina Nebula. The wall of the nebula is sculpted by intense ultraviolet light and stellar winds of extremely massive hot young stars. Scientists were amazed once again. Compared to Hubble, JWST produced a much sharper image, which is especially noticeable when the images from both telescopes are superimposed. In the James Webb Space Telescope's image, you can see burning dots in the background. They're not stars but very distant galaxies. The bluish haze that seems to rise from the celestial mountains is actually hot ionized gas and dust ejected from the nebula by the continuous radiation of young stars. So now that you've seen these incredible images, which one is your favorite? Give us a like and sound off in the comments. The James Webb Space Telescope has just begun its cosmic mission, So make sure you stay tuned here by subscribing so you don't miss out on anything. Thanks for watching.